Yes, this is our session.
We can start with the first presentation. Carla, good morning. We can start.
Okay, great.
And you share your desk. Thank you.
Okay, you see it. Good morning. I am presenting you the methane supply chain from production to transport and consumption in the light of EU strategy. This work is part of the project work for the Lewis Business School Master on circular economy. It is in the framework of, it is developed in the framework of the decision under Green Deal of the European Commission that foresee that Europe will be transformed in the first climate neutral continent by 2050. It also takes into account the recent decision under COP26 in Glasgow that foresee the reduction of global methane emission by at least 30% by 2030 compared to 2020 levels. Of course, as I introduced, this work is developed in the framework of circular economy that is not just a way to manage waste, but also a change of mind to address the global environmental challenges. For
Carla,
sì? Yes?
can I ask you to wait a moment, because the beginning of our session is 9 o'clock, also because we must wait other people that can connect the participant, not only as a presenter, but also as auditors. Then it's better to wait the official time to start for the presentation. I want also add some other information for you, because in the program we were they had 4 speakers, but the first speaker in the list, perhaps you know the program.
Sorry,
Pardon?
but Giacomo Benini, he will not participate because
yes, I know. I was asking if there are other authors of the of the presentation. Then I asked if there were another co-author of the project, but till now we don't receive any information about this, the presence of Dotti. Then for the moment we can stay on a program of 3 presentations, then 3 speakers that I think you are. Carla Mazzotti, Marzia Sensini, and Consuelo Rubina Nava. I think we are the present. That means that we are a global time of 1 hour and a half, starting from 9 that each of you can use. Is more than the scheduled before, because you have more or less 25 minutes. I hope that at the end of each presentation we can also receive some question, that there is a potential question and answer session. I don't know if we will receive questions in order to give you the possibility to reply, to answer to the questions. Or other questions that among us we can make. In any case, I think it's better to wait the official time to start. I don't know if all is clear for you or you need other information before we start.
To me,
Yes,
it's clear. Thank you.
That's perfect.
It's perfect. Thank you.
10 minutes and we can start. Thank you, everyone.
Okay, then we have another minutes and we start. Not confirm of Dotti presence, then we can start in the formation we are now. We are the team of the session. Well, then we start with the first presentation, the methane supply chain from production to transport and gas consumption in the light of the EU strategy. Presenter Carla Mazziotti from the National Research Council, Italy, is the Italian Agency for Research. I suggest that before you start with your presentation, Carla, you make also a short description of your curriculum in order to better summarize, better than me, I think, your curriculum. Carla.
Thank you. Good morning. I'm a technologist of the Department of Engineering of National Research Council. At the moment, I'm the energy manager of the area of research of Florence. And in the department, I collaborate with the energy manager of the whole CNR infrastructure. I worked for a long time, 18 years at the Ministry of the Environment. Now it is MIT, Ministry for the Ecological Transition. And here I present my work of thesis at the Lewis Business School on circular economy management, waste and energy management. This work, it is developed, follows the European Green Deal, that is a program launched by the European Commission in 2019 to make the Europe the first climate neutral continent by 2050. It also takes into account the recent decision on COP 26 in Glasgow, which aims to reduce global methane emission by at least 30% by 2030. There is a big effort for the European Union, huge investments for the energy sectors, and it is foreseen that it will produce a new qualified job. I want also to underline that in this summer, in July, the Commission launched the program Fit for 55 package, also to contribute to the net greenhouse gas emission reduction. And in these days, it is presenting a directive package, a legislative package concerning also methane. This is a very short synthesis of methane characteristic. We see that the methane atmospheric emission ratio is grown steadily in the recent years after industrialization. On the left below, you see that actually there are the measures taken to reduce methane emission are in Europe are very effective, but actually this is a problem, global problem, since the lifetime of methane it's about 12 years, so it circulates in the upper, the lower globe. And in this sense, the program of UNECE is very interesting to the issue to abate methane concentration under the framework of long-range air pollution, transboundary air pollution. It also collaborate with UN FCC, insomma, climate change conversion, because methane has a substantial greenhouse effect. So to control this emission contributes to reducing global change. Slide, I summarized main action in the EU strategies to reduce emissions. The first pillar is measurement, reporting, and verification. But you see many other actions, for example, the Copernicus programs, and at EU level, the revision of many directives. The main sources are agriculture, waste and wastewater treatment plants, and energy. So the following slide, I have a picture of the national situation. Of course, improvement of the market for biogas is also a measure to follow, and is the main direction of my paper. I have already introduced this measure of the 55 legislative package. In the graphic, you see that in the left side, the linear economy, and compared to the right side, circular economy, when products are used and disposed on the left, or especially in a biological context, they can come back in the nature and contribute to regenerate the environment. So the first pillar is this one of the circular economy. Then there was also an assessment of techniques connected to carbon capture and storage, since also to use the CO2 capture carbon for the production of synthetic methane can be a technique to prevent greenhouse gas emissions. And finally, I present a use case on a company that produce a biogas, biomethane generation system, an upgrading system to purify biogas to biomethane. Yeah, I have a slide on current status of national methane emissions. These are figures from the fourth report, biennial report of Italy, taken from the Ministry of Economical Transition, Environmental Transition. And you see that very important sector is agriculture, that contributes very much for enteric fermentation and manure. And in this framework, the EU legislation as specific decision under the IPPC directive. I worked actually 8 years at the Ministry of the Ecological Transition at the direction that follows these topics. And in the IPPC brief documents, but conclusion documents, there are specific indication for the competent authorities to provide the authorization for very large installation over a certain threshold defined by legislation. There is also a very important contribution of methane from the waste sector. And of course, also in this field, there are BAT conclusions developed by the European Union at the IPPC Bureau in Sevilla, that is a European Commission table with the participation of member states and industry and NGO interested to the topic. And okay, I have a synthesis of measure upstream, downstream measures for farming. I found also this very interesting issue from FAO that actually takes very much into account the circular economy principle. First of all, efficiency and also minimizing waste, and also capitalize on nature-based solution and so on. Afterwards, I have few slides of natural gas operation with figures from in Europe and in Italy. These are figures for the Europe. I want to to underline that actually in this natural gas operation, fugitive emissions in the EU accounts for about 5%, while in Italy national estimates are about 1%. Actually, we see that natural gas flows in the Europe in the sense of geographically and for a very long distance. So this amount is anyway very substantial. Here I took some slides from my studies on IPPC national installation. The following two are for chemical plants. The competent authorities usually prescribes the implementation of LDAR, leak detection and repair program, that is that companies frequently develop in the framework of voluntary certification of 4001. And so we see here a Deming cycle, plan, do, check, act. This monitoring in the years becomes more smart because the possibility of use automatic sensor in key devices like a pump valve, so that they can analyze the data and act with maintenance, preventive maintenance, or other actions to prevent fugitive emissions. And actually, as we see in this slide, these preventive measures as advantage for the operators, because of course there are evident costs to prevent VOC emission, because this is a valuable material for the company, but also there are hidden costs like repair, incident, waste energy, plant inefficiency, but also there is a very important issue like connected to the image of the company. On the top right side, we see the increasing trend of removal of VOC, and we see that this company actually had a very nice result, 8% of removal compared to the first year, since actually these techniques and together with certification, environmental certification, helps the operators of the installation. And this is the case study of Tonissi Power with ATW Energy Technic GmbH. As I told you, this company has an upgrading system that works together with a food and drink industry that generates wet waste with a high organic content that can be disposed. Actually, in a system that employs anaerobic digestion, it is possible to provide value from this kind of organic waste to produce biogas that can be upgraded to biomethane. And of course, together with the biogas, there is a compost that is produced that can be employed instead of mineral fertilizer or synthetic fertilizer. And here I have the system of the company. And you see that at the end we have methane and CO2. And we have, of course, in purifying biogas, we reach 90 to 99% of methane. That is important value. And here I have the figures of the levelized cost of generating electricity from biomethane. That is about 50 to $190 per megawatt. In fact, this biomethane can be employed to produce energy. Also, the heat can be recovered, and of course, here we have many opportunities for business. This is the framework, the context of circular economy, how it fits in the Resolve model developed by the MacArthur Foundation. I want to pinpoint only a couple of issues because very long, and the importance also to modernize the system with digitalization of data that can help the management of the system. And another issue that I want to pinpoint here in this framework, also on circular economy, in the slide, is the issue of the citizen awareness, because sometimes this kind of installation find a strong refuse from the local from the citizen, and to have the installation in their neighborhood. And actually it is very important to explain what are these kind of installation. Perhaps this installation, people think to incinerator. There is a sort of misunderstanding because this kind of installation is a system to recover all the matter. There is very small amount of waste. Organic waste is put again in the circle to produce biogas, then biomethane, and compost. It also responds to the extended producer responsibility that is stated in the circular economy legislation. That is the responsibility of the producer to foresee to think at the design of the system, what are which are the possible ways and what to do with them to put again in cycle, so they are not anymore waste but secondary raw materials. And I have some figures, economic figures, CAPEX and OPEX for operating, for installation, decommissioning, and so on. We see that costs are very relevant. Actually, I have figures slightly different from the Commissioner Simpson. In this recent seminar on biomethane, I found out on the press corner of the European Commission recently, a couple of days ago, and actually the hope is that this kind of system can find a support, an economic support in the next directive, like other renewable energy sources, because at the moment the technique is costly, but this is the future, and this will make costs lower. And here I have a couple of slides on possible other taken from literature, scientific literature, before the anaerobic digestion. The system can foresee a step for the production of polyhydroxy alkanoates that are that are polyester, but they are bioplastic that can be used, they are compostable, that can be used for medical application, pharmaceutical packaging, also textile. There is a company that produce clothes with this substance, and also here I took a study from on a biorefinery where there is biomass catalytic gasification and then methanization of the CO2 produced with the hydrogen coming from the IGCC installation. Actually, this hydrogen can be also produced from renewable sources. So the hope is that this package developed under the umbrella of Fit for 55 package can promote this kind of synthetic fuel, synthetic methane, but preparation documents show that there are also other e-fuels that can be produced coming from biomass feedstock. So this is my final slide. I hope to be in time. So I just want to recall few issues: the monitoring, verification, and reporting, the updating of VAT conclusion brief document of the European Commission, and the digitization of the network to improve, to optimize the system, and of course the energy efficiency first, then the prevention of the production of waste, in this case, the organic material food waste, the promotion of these techniques to reuse the carbon content of biomass. And finally, I want to underline that this pandemic situation was actually an event that evidenced the fragility of the system, but at the same time, it was also the opportunity to take a direction to promote these environmental and climate neutral measures. Thank you. If you have some question, I'm here.
Thank you, Carla. You used all the 30 minutes. Then for you has been lucky that the Benigni presentation has not developed. But I ask if there are any questions. At the moment, I don't see questions. I ask you, if did you analyze one of the points that you developed was the biomethane production starting from waste, and also the possibility to produce energy starting from waste. There are any project or then any assessment of the target that we can reach? For instance, you mentioned the Italian situation, the Italian data at Italian level in 2030 in this sector.
Actually, I don't understand very well the question. If you can explain.
I asked you if the energy production starting from waste is what is the potential of this activity, or there are projects in this moment that can, because it's one of the way perhaps to try a solution to the waste problem that in Italy.
Yes, concerning methane.
In some areas is very difficult. Yes.
Concerning methane, actually, I saw you the slide of the Commissioner Simpson. The Commissioner said, and I fully agree, that actually biomethane doesn't fit for the distribution line of methane. In my opinion, to produce biomethane locally, it's better because, of course, the fossil methane circulate over Europe in a geographical sense. So this methane can be used for energy, of course, so eating, cooking, everything, but also it can be used also for mobility. We have infrastructure also for the mobility, for example, also some heavy duty vehicles and so on. And the advantage, of course, to use methane, we saw it historically also that we in Italy we switch from carbon gasoline to methane to prevent air pollution. And because methane is a clean gas, it prevents also the formation of nitrogen oxides, particulate
Yes, yes,
matter.
I was asking if there are any data
this,
on the amount of this potential production.
the amount of we see that we have many organic waste. I don't recall the figures that actually we don't use in Italy. It seems to me that we have in my thesis we have about only 300 installation or so. If you want me to check. And but we need more. I live in Rome. We need, for example, in Latium. I don't want to
Okay,
make
okay. Thank
a
you,
political
Carla. Thank you, Carla. Now we have the second presentation. The speaker is Marzia Sensini, sorry. The title of the presentation is Solidarity Measures Assessment of Strategic Gas Storage Coordination among EU member states and EU natural gas supply resilience. Then we pass from the gas as biomethane to the natural gas, obviously. And I asked Marzia Sensini, as I asked Carla, to make a short introduce herself and make a short presentation of her curriculum. Marzia.
Yes, thank you. Good morning, everyone. So I work as a postdoctoral researcher at the Climate Economics Chair at University Paris-Dauphine. The work that I'm presenting today has been developed with Professor Adam Oaks and Sarah Jarola as part of my PhD at the Department of Chemical Engineering at Imperial College in London. I've been also working for several years in the field of gas, natural gas, within the
many years. You are so young.
Not so young. In the corporate strategy department of SNAM. So here we are today with the solidarity measure. I think probably you've seen in the news these days about like Russia not bringing gas to Europe. So this is actually turned out to be like a very hot topic these days, but not when I started it. So here we are. We're going to see the context, the methodology, and the results and conclusions. So the overarching question that I ask myself is, can energy security be enhanced by solidarity among EU member states in response to natural gas supply crisis? And to answer the question, three aspects needs to be looked at. One is gas supply in the EU market. The other one is gas storage, of course. And then the last one is gas energy security. As far as gas supply in the EU market, why gas? Gas has a crucial role to play in the energy system up to 2030 and possibly up to 2050. No, not only that, but today is the second largest primary energy source in the EU. It accounts for 25% of total EU energy mix, 20% of electricity generation, and 37% of its generation. What we know about gas storage is that it has a dual role to play in the market as a volume flexibility. So it's a crucial component on the gas market to balance the market as a commercial storage. Not only that, but it has an insurance value that is pivotal to the role in securing of supply. It ensures continuity in case of supply interruption with strategic storage. In Europe, only Italy has a strategic storage mechanism in place. And what is strategic storage? Is a prefixed volume of gas that is set out. So it's taken out of the market, basically. So it's a non-market gas volume that can be used in case of emergency. Other states have storage obligation, which you can see is the majority of them, 9 member states. And storage obligation is our obligation that are placed on market participant to have an amount of gas taken out, not taken out of the market, but stored, so they can help mitigate possible market failure. The research goals. So we look at the literature and on natural gas supply disruption and the literature on natural gas storage. And what we do is that we look at the intertwine between them, and we see that there were some missing aspects or element. And so this is basically our contribution to the field, is that we are looking at high impact, low probability events that are mega disaster where the market is unable to meet demand and policy intervention is required. We look at strategic storage, as we mentioned what it is, and then we look at solidarity. Solidarity is cooperation of a regional risk group. It's been defined in the 1938 regulation of 2017 of the European Commission. They introduced this solidarity mechanism that sees member states to cooperate and coordinate among one another in case of energy emergency. And then the last aspect is resilience. So it's the ability of any supply chain to respond to unexpected events and maintain continuity of operation. And this is absent from the literature in terms of strategic storage. So we combined all these elements to answer our initial question. So what we created is a linear programming optimization model to model the full natural gas supply chain with a stochastic approach, a two-stage stochastic approach to model uncertainty scenarios with a discrete probability that has been defined based on high impact, low probability event with historical and real world data. The reference period is that of Burian in February 2018. It's extreme cold weather shock that hit Europe during that time. And our framework of optimization is a short-term framework, namely 7 days, because we've looked at past crises and disruption of the network, and we've seen that they only lasted from few days to few months, and that the worst period was like the first 7 days when the disruption or the crisis happened. So you can see a basic model structure down there. The input of the model are demand, production, transmission, LNG, and storage. We then minimize cost with the minimum cost equation, and the output are costs, and so on all those variables that I've introduced. So this is the model structure. Basically, what we have is we have member states, the boxes, and in each one of them you can have demand, and storage, and it can be supply, that can be extraction or LNG. And you have flows that goes from one to the other region or member state, and can be one direction or bidirectional. And then you have high impact, low probability event that disrupts the flow in 3 probabilities. So the probability of occurrence is E1 when like no event occurs. E2 is when there is a material failure. So some technical aspects goes wrong. There is like an explosion, like we've seen in 2017 in Baumgarten, or E3, the probability E3 is ground movement. So it could be earthquake or it could be landslides. Here is an illustrative network structure. We mapped the entire European network with nodes, European nodes and non-European nodes, so major importers within the system. And these are like 40 regions altogether. We have flows and pipelines, and then we have the lump sum of storage that's commercial, strategic storage or obligations, production, and LNG terminal. So as I said, as I already mentioned, we have a minimum total system cost formulation of the model, subject to constraints that are constraints placed on demand. So a regional mass balance needs to be in place. And then we have resource availability, storage capacity, infrastructure capacity, and LNG port capacity that have limits on them. We have first stage variables that are those variables that do not move with the dynamic of the demand, that are like less able to, well, they have a different time frame with respect to how the market moves. And so these are quantities that we know a priori, and they relate to storage. And then we have second stage variables that are transmission, production, and supply through LNG terminals, and they move with demand and are more flexible. So that's why the system can work on them. The model has been applied in 3 applications. So we have like 2 prior publications, one to validate the model, the other one to look at the coordination of strategic storage. And this one is on solidarity among member states. And you can see on the right, one of the 13 regional risk groups that have been defined by the EU, and this is the Eastern Gas Supply Risk Group from Ukraine. So this is the scenario that we formulated. We use the 2-stage stochastic optimization linear programming minimum cost model with increased temporal and geographical scope. So we looked at 7 days plus other days up to 14. And then the geographical scope is we grouped the member states into regional risk groups. The scenarios that we formulated are 5. We have a reference scenario, and then we have the 4 disruption scenario. And each one of them gives us an insight on a different aspect. So the Ukraine disruption sees a 100% disruption of the flow from Ukraine. And the insight is on Eastern gas supply dependent countries. Then we have the Russian disruption, and the insight is on member state with little diversification of sources. We have the Norway disruption scenario, and so this one gives us an insight on the core of the EU market. And the North Africa disruption scenario is on the peripheral EU gas network, namely Spain, Portugal, and Italy, that are ways where like the North Africa gas comes in Europe. And for this scenario, we use the strategic storage, whereas for the reference scenario, we don't put in place the measure. So results are discussed with a focus on supply mix, as we are about to see, on demand curtailment or survival times of the system, and on system cost. And I'm going to present the data at the EU aggregate level, although we have data for each of the scenarios that I've presented. So we look at the supply mix here. For production, import, LNG, and storage, during every time step of the crisis. So you see Burian, day one of disruption and week one of disruption, and we compare it with the pre-disruption levels. So we see a reduction of import in favor of storage mainly, and then of production when we are like towards the end of the crisis at day 7. So you can see that at the beginning import is 53%, and then it goes to 19, 9, and 19 again, whereas production spiked up at 56% during the disruption week 1. Where we also looked at the volumes, there is an increase in LNG and storage volume, 30% increase on import of LNG during week 1, and storage is 32% at day 1, 65% of which is strategic storage. So if compared to the reference scenario. So LNG and storage have a really nice interplay between one another during disruption. As far as solid system cost is concerned, we see that solidarity reduces up to 15% of total system costs, if you look at the chart on the right, and also 70% of LNG costs. But so the graph on the right is a disruption scenario with the strategic storage compared with the reference scenario with no strategic storage. But if you look on the right, we still have reduction of cost within a disruption scenario with and without strategic storage. It's less evident, but it's still there. It's 12% and 43% of LNG cost. And finally, we look at resilience. So this graph may be a bit difficult to interpret, but I'm trying my best to explain it to you. So you'll read it from the right to the left, and it shows strategic storage depletion. So the blue dot is at the start of the disruption, and it goes to the red dot at the day 7. So if you can see here, solidarity improves network resilience during crisis, because at week 1, if we look at Italy, for instance, we still have 40% of strategic storage left in place. And when we run the model day by day after the day 7, we see that at an aggregate level, the system doesn't curtail demand until day 14. So it's a 7-day increase of resilience for the system, which during a crisis could be really helpful. So finally, a conclusion. So we saw that there is a strong interplay between LNG and storage during the emergency. We have also seen that no market-based measure, as the storage-based solidarity measure, can be a cost-effective alternative to market-based one. Strategic storage as an insurance value that can benefit the overall system cost. And then we've seen that solidarity among member states during high impact, low probability event lessens the impact of the event itself, both in terms of cost and in terms of system resilience. So there is a role for strategic storage and solidarity in the increasingly interconnected EU energy system, and they can really help in the path toward the energy union. So that was it from my end. Thank you very much for listening, and I hope you'll have some questions.
Thank you, Marzia. Thank you for your very interesting presentation. The work you made is particularly interesting in this moment. Unluckily, we are not yet real solidarity among the European countries, and each country moves alone, making it's a decision, and we are talking today of the Italian decision, the Spanish and French and so on. But we hope that we can arrive in a few times to
right.
a real solidarity. There are any questions from the participant or the other speakers? No, I don't see any questions. Then we'll go to the last presentation. Consuelo Rubina Nava is the presenter of the speaker for the last presentation, Retail Price Convergence Across EU Electricity and Natural Gas Markets. As for the other speakers, Consuelo, I ask you to make a short presentation, a short introduction of yourself and your curriculum.
Thank you so much. Thank you so much. I just want to share also that now I'm a little bit in troubles because I tried to share the slides, but I'm not able to do it. I'm with anxiety, but okay, I don't know why. Now I'll try to solve to solve the problem. Sorry. I don't know why they are not allowing me to share.
Did you send your presentation to the?
No, but it's not a problem. I think that now I can solve it. Okay. Now let's try it if I'm able to. Okay, now it's better. Okay. Thank you. I'm sorry. Are you able to see the presentation now? Okay. Sorry for this.
Right.
Okay. 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 It's here. So it's better. So sorry for this beginning. So my as you kindly present me, I'm Consuelo Nava, and I'm a researcher in econometrics at the University of Turin. And I worked with especially Ernesto Castetta over some works in the electricity and gas field. So of course, I have to be honest, I'm not a real expert in the electricity or natural gas markets, but I'm just looking at some methodological issues behind some different research and try to find out a suitable solution to them. And this is still the proposal of my contribution of today. As you anticipate, my contribution, which is a joint work with Ernesto Cassetta from Union University and Maria Grazia Zoia from the Cattolica University of Milan, is entitled Retail Price Convergence Across EU Electricity and Natural Gas Markets. Due to, in reality, to a time constraint, because it's quite a, I think, quite an interesting topic. In reality, I will concentrate more on the electricity side, which is the part of the work that we have already accomplished and almost finalized, so that I can propose you some also interesting conclusion over our analysis. Let's start immediately looking at the background. In particular, when we look at the European Union, we think that there are different indicators which measure the integration of the energy market in general, so including both electricity and gas, which are in general the average prices and the degree of price convergence. Therefore, the study of price convergence became interesting in this perspective to analyze the effectiveness of the actual harmonization policy in the electricity market and the tentative of reducing the barrier across different member states. Of course, what we are expecting is that when there is a full integrated energy market, the electricity should be produced in one member state and then could be delivered to another industrial or to other countries for consumption at industrial and residential levels. However, a consequence of this increasing competition prices, this increasing competition, we're expecting that prices would progressively low down and also become less volatile. And therefore, once again, the evaluation of the price conversion across member states could be an insight of also the effect of this increasing competition. Moreover, the reform behind the national electricity prices over one single market is, however, a really long process, which takes time, and that at the end seems to be not really already accomplished in a full way. Therefore, what we are observing, at least looking at in general at the member state, is the presence of a large heterogeneity in the retail electricity prices, and therefore our aim is to try to investigate the cross-country convergence, if there exists, or if there exists form of clubs, of group of EU member states, accordingly separately with respect to the residential and industrial and user electricity markets, take into account data from Eurostat data from 2007 and 2021. Just be reminded that in reality we are considering the data of the first semester, so we could also take into account the 229 that is of course not already concluded into our analysis. Our main research aim rests on the need to investigate the presence of multiple clubs through the use of these techniques, which is called, and then I will just depute a few minutes to discuss the advantages and the main aspect behind the club convergence analysis. And on the other side, we would like to investigate if there are differences across these two markets. So on the one side, the residential, and on the other side, the industrial and user electricity market. Concerning club convergence, in general, the convergence, there are different techniques which could be employed to analyze the convergences of prices. The most widely known are, at least to my, at least accordingly to the research, to the literature review that I undertake, that we undertake in this field, are mainly the beta and the sigma convergence. However, in the presence of heterogeneity, in this case of the electricity prices in the different EU27 member states, it could be that these two types of analysis could fail in addressing the characteristics that might lead to identify specific cluster or subgroup of which converge to specific equilibrium states, and on the other side, it became quite difficult to analyze with this beta and sigma convergence the movement or the persistency of this specific group over time. And therefore, it could be used, the so-called club convergence analysis, which is principally the main references is Phillips and Soule, 2009 and 2007, which developed these techniques and announced main advantages, which I think could be of interest for this empirical analysis, that we undertake. And in particular, they allow to construct the so-called relative transition path, different for each member state, and therefore to enhance eventually individual heterogeneity in the market. One of the main advantages is that this methodology does not impose any prior assumption, and therefore does not neither require stationarity of the time series that we have to analyze, the time series of each member state according to these two different markets. And then it allows a data-driven approach which allow the emergence of eventually possible different club convergence. Therefore, what we would like to use, the way in which we would like to use this analysis is to highlight eventually the presence of the effect, of real effect in terms of electricity prices, of the harmonization and integration process undertaken at the European level, and investigate the effect of this eventual this harmonization on the electricity prices, given, of course, different regulatory framework and different market competition at member state level. Are the main features of this cloud convergence, as I have anticipated, is mainly, this is a technique mainly developed by Philips and Sol, but is it introduced by Baumol 1986, and it is based on a first step, which is the filtration of the time series for each member state from, I just remember to you, from 2007 and 2021, of the electricity prices, and in this case we take advantage of the so-called Odryk-Prescott filter for removing the cyclical and the seasonality component, therefore only to take into account the long-term component behind each time series. Then each of these, let's say, of the element in the trend, it could be decomposed into two parts: a systematic and a transitionary component. However, to estimate the presence of cloud convergence, we need to further to introduce the so-called common component μt, which can be employed to represent, as reported in equation number 2, the price of country E at time t. Of course, this is a model for panel data, and it is based on the identification of this common component, or common path if you prefer, μt, and a systematic, a systematic and idiosyncratic component, which is of course time varying, and which measure the differences between the trend of the price with respect to this common component μt. Now, according to this representation, we could construct the so-called relative transition path or relative transition component, which later I will let you also see how they could be represented easily for the two markets that we investigate, which is simply the ratio between the trend of country E at time t and the average across all the member states. The interesting thing is that in the presence of convergence, so meaning that the component delta IT tends to converge to a constant term, which is not, let's say, time varying, delta I, we observe that the transition path, the relative transition path tends to converge to 1, and the so-called cross-sectional variation HT measure as in equation 4 converge to 0. So taking advantage of this representation, Philips and Sol specify the way in which we can also construct a suitable test called log-T test, which allow us, also in presence of heteroscedasticity and autocorrelation, to assess the presence or not of an overall convergence. In particular, it takes advantage of the decomposition of this idiosyncratic component delta IT in the trend component delta I, and in a part which take into account through the component to the element alpha, which is the rate of convergence of the presence of a convergence. Therefore, when this second term is said to be equal to 0, we have evidence of a convergence. To better help also the interpretation of the results that I will propose you, in reality, we further transform these relations, taking advantage of the log of the ratio between H1 and HT minus the logarithms of this penalizing function called LT, also introduced in equation number 5. As you can see, we can take advantage of this representation because it linearizes the relation, linearizes the model, and therefore we have this component beta, which is the parameter which allows us to estimate the presence of a convergence. It incorporates, now I don't enter too much into the detail, the convergence parameter alpha. And therefore the so-called log-t test that we will employ in the analysis, it simply rests on an hypothesis of convergence, of overall convergence, in which the parameter beta is equal or greater than or equal to 0, and it allows us to assess also the convergence in subgroup, eventually in subgroup. The procedure that we will use, the algorithms, is an iterative algorithms, which is the Phillips and so one, and gives us some interesting results. For our analysis, we are employing the average national retail electricity prices from the Eurostat database. They are expressed in euro for kilowatt, and the time span is from 2010 and 2021. Of course, we are not including the United Kingdom, given that, of course, 2021 is anymore in the European Union, so we concentrate on the EU27 countries. We consider residential and industrial consumers, and in particular, we consider as a reference the medium size one. We have at the end we have at the end 30 observations for each country, 50 for the residential and 50 for the industrial one. In particular, here we have the first preliminary result. This rests on the first step, meaning the construction of the Audrey-Prescott, the extraction, sorry, of the trend component through the Audrey-Prescott filter for household and non-household consumers. As you can see, at least from this first figure, we can appreciate the fact that the prices seems to be more concentrated but also as expected in the non-household market, so for the industrial sector. It is just a preliminary step. What we are going to do is to construct our club convergence analysis, taking advantage of this filter time series. The first step, the first real step, is the construction, so the use of this log-t test over the full sample of country that we are considering, so over the 27 EU countries. What we can announce is that we have a rejection of the null hypothesis. Therefore, there is not an overall convergence over the EU countries. We have some specificity, some heterogeneity that must be further investigated, both in the residential and in the industrial, both for residential and for industrial consumers. The interesting thing is that this is the preliminary step which suggests the need of further investigation, taking advantage of the club convergence analysis. Beta that you are seeing here is just the estimate of the speed of convergence, right? So in reality, the t-value and the associated p-value associated to this test suggests the rejection. Therefore, we enter a little bit more into the details, taking advantage of analyzing first the residential market and then the industrial one. Concerning the residential, so the households, at the end, there is the emergence of 3 different clubs. The coefficient beta, as I suggested suggested before, represent the speed of convergence. So we have a first club, which is quite numerous, is a club with 11 units, which collect, for instance, France and Spain, as you can also see from the map, and is the club which has, let's say, a middle convergence with respect to the others. In fact, the club that converge with a slower trend is the third one, which is simply formed by Luxembourg and Italy. In this case, we also have different countries which does not show a convergent path similar to all the others, and therefore they are considered the divergent, the so-called divergent units. To enter a little bit more into the details of the construction of this club, what we can observe is the way in which the relative transition path behave. So as you can see from this different plot for each club, we have, if you look at the third club, for instance, which is maybe the one which is so easier interpretable, we have all the countries that show relative transition path above the average and the decreasing one. In particular, the Luxembourg has a U shape, which could also be assimilated to the U shape of Romania in the first club, as well as to the Netherlands trend. On the other side, we have, for instance, always in the first club, Cyprus and Spain, we show an inverted U shape. Therefore, they have a first period of a catching up and they decrease again. This is an interesting club because it has an important convergence around the average. So as you can appreciate, is around the average, differently from club 2 that show a convergence below the average, or club 2 or club 3 above the average. So here is just the representation of the average transition path, just to help, say, the interpretation of this specific the specific country behavior described before in this in a more synthetic setting. But at the end, is just the representation of the fact that the third club has above the average transition path above the average, while, for instance, the second one is below the average. This is, of course, a first preliminary result of a form of heterogeneity in the markets. Looking now at the industrial market, we once again, also in case, we have 3 different clubs. The way, however, this is quite immediate looking at the map. In reality, there is not a real overlap of the club formation, meaning that in reality it seems that there is a different behavior for industrial and residential markets, in terms, of course, of electricity price convergence. And we have also different factor in the speed of convergence. There is a really huge club, the first one, which is, let's say, it's the slowest one in terms of convergence, which collect, for instance, Italy and France and Spain. And there are other 2 clubs, for instance, the Ireland and Malta form the third club, which show the highest convergence rate. If we look at the relative transition path split by the clubs, we can observe once again that the second club has let's say, a convergent path which rests on value below the average, while the third one, which is made by Ireland and Malta, has a relative transition path above the average. Around the average, we have the behavior of the first club. This is even more evident looking at the average transition path for the 3 clubs, which enhance the aspect that I have highlighted just before. Now, I've just tried to find out some conclusion and highlights further research over this contribution, this preliminary contribution that we try to draw. But first of all, we see that there are really different transition paths in terms of price conversion when we compare the retail and the the domestic side, meaning, sorry, the industrial and the domestic segments. Therefore, there are some interesting differences that can be maybe further investigated through maybe the analysis of the local macro fundamentals, which maybe can drive some further insight on the reason for which there is this evidence. When we look at the domestic user, we have a higher level of dispersion and heterogeneity of the prices, while, for instance, there is a higher level of concentration and therefore a more evident long-term convergence in the industrial electricity prices. These differences also within each segment, in reality, seems to be not justified by structural features in terms of market fundamentals. For instance, the electricity generation mix, the market integration of the policies, and as well as the investment, for instance, in cross-border transmission capacity. While, for instance, it seems that it is more justified by the fact that there is a gradual relaxation of the regulated and consumer price regimes, especially when we look at the household market. For instance, this is the result of a change in the priority in the energy policy, as well as a greater attention to the ecological transition and the security of the supply. Our results are, at least in the electricity market, seems to be really in line with the Poly 2019 contribution, which suggests the persistence of important difficulties in reducing the end user electricity price dispersion across the member states. And just to draw the last conclusion, we have these important differences seems to be also related not only in association to these difficulties, but also with different public intervention, with some disparities in the range of household and industrial consumer under the regulated end user prices, as well as different criteria used among countries in different energy component. If we want to draw some policy implication from our club convergence analysis, what we can say, at least at this preliminary level of our analysis, is the need of a stronger cooperation for the public intervention and regulation to allow a speed up of this auspicated price convergence. Also in the support of the decarbonization of the electricity system. In terms of further research, we are also investigating the natural gas market, in which there are maybe more contribution, in which also these techniques of the convergence analysis is maybe more known than not in the electricity field. And we also envisage, also in this case, unfortunately I don't have the plot, but we have also in this case seen important differences between the two markets, the electricity and between electricity and gas, as well as important differences for the type of consumers. Of course, if you have some questions, it will be a pleasure to respond. Thank you so much.
Thank you to you, Consuelo. I don't know if there are any questions on your presentation.
I have a question, if I may.
Marzia?
Yes, sure, Marzia. It's a pleasure.
Thank you. So I'm not sure if I understood correctly, but so it's a policy intervention that creates the non-convergence for the household prices to have like so many non-convergent countries in the slide that you showed like before.
Here, I think.
Yes, here.
Yes.
So yeah,
well,
the following one. Yeah. Sorry.
No, the following. Yes, this one. Yes.
Like this one, you have so many non-convergent member states, and so this is due to the policy interventions that are.
But we suppose we are still trying to given that it's still a work in progress, we are still trying to investigate all the dynamics for each different country, which is of course quite different across member state. However, the idea is that it seems that there are local specificity which, for instance, induce this non-convergence. So as you suitably capture.
Okay.
Thank you.
Thank you. Really interesting research.
Thank you so much, Marcia. You're really kind.
I had a similar question because you mentioned, yes, this no convergence or difference between different clubs, but also you mentioned another point that is for me difficult to well understand, that the non-convergence is not connected to the fundamental of the market, the difference that are in different countries for the market fundamentals.
Yes,
Different cross-convergence clubs seem not to be related with the common structure of future term of market fundamentals. It seems not easy to understand due to the, for instance, to the increase of the renewable energy that are non-plannable energy. Then that represents increase of cost, for instance, that is not easy to
capture through the prices. I agree. Yes, I totally agree with you. Yes, but the interesting thing is that when we try to investigate the electricity generation mix for the different countries, let's say the policies, the policy for market integration, it seems that there is not a rule, let's say, that justify the formation of the convergent of this club. And the unique, at least for the moment, maybe we have to further investigate this, is that in reality it's really more associated, this convergence, it's really more associated, I mean, envisage this disparity across the countries. Therefore, it's really maybe a stronger level of cooperation, which allow to envisage a higher speed in the convergence. At the end, this technique, at least methodologically, rest on the speed of convergence, so enhance the speed of convergence and the level of convergence at which the prices tends to. There is, of course, I mean, I don't want to be too net, because in reality there is an evidence of convergence for the majority of the European countries, because we have this huge club, one for the industrial, as well as at the end also the first club, which is quite numerous, for the household market, which has an important convergence. So they have an important convergence behavior and collect an important amount of countries. But at the end, for instance, we have together, now I'm not an expert, so please take this with all my effort to try to find out a suitable response to your question. For instance, countries which has important differences in terms of, let's say, maybe energy generation mix or fundamental market structure. So we don't find out a real explication which allow us to justify this non-convergence or this not really not this heterogeneity in the European scenario.
But the market design that the new European directives try to introduce can be a passage, can be a step to arrive higher convergence, or you think that we remain always some difference between the different clubs you mentioned?
Well, no, at the end, I think that in the long run, I omitted a piece of the analysis. I'm sorry, but just because at the end I was trying to find out the time in a suitable manner, to manage the time in a suitable manner. But the interesting thing is that in reality, you can. I mean, there is a technique which is based on on a long run. Let's say behavior, on the investigation of the long-run behavior. So let's say in a more prospective way, as you suggest, which is, let's say, a sort of merging algorithms. And it suggests, for instance, for the resident, the persistence of this unit as divergent units, so Austria, Belgium, Denmark, Germany, Hungary, Ireland, Malta, Poland, and Sweden. Well, for instance, the scenario is different for the industrial, because we still have the third club, which is Malta and Ireland, still with a really own behavior in terms of convergence. Well, for instance, there is an integration of the second and the first club in the long run, I think envisaging exactly so that you are suggesting. Of course, I'm not at the level of this of the research. I'm not ready to say that it could be driven by the renewable energy, the policy over the renewable energy. But this is a really interesting point that we have to study more in deep. So thank you so much.
Thank you. Thank you, Consuelo. Thank you, Carla. Thank you, Marcia, for your presentation. Very interesting. We arrived at the end of the time that we need to respect. Then good work for you for your studies. Thank you.
Yes, thank you everyone.
Thank you.
For your
Thank you,
attention.
everybody.
Thank
And
you.
have a good time. Goodbye.
Bye. Thank you.
Bye-bye. Thank you.
Bye.